Okay, I want to continue where we left off today on worksheet number 6, looking at definite integrals. And just as a reminder, it's called a definite integral because we're evaluating it over some interval, right? So we can see we're evaluating it from -1 to 4. We're finding the area under the curve 2 minus 2x from -1 to 4, as we saw today. That's what we call a definite integral, right? We're finding a definite integral. And again, as we saw today, when we integrate, we should always have a plus c, right? But in a definite integral case, we saw that the c's actually cancel out, right? When we do c minus c, those c's cancel out, and we're left with just a number. So when taking a definite integral, we don't need to add the c values, okay? So that's one of the things we kind of saw today. To be honest with you, this is a pretty simple process now that we kind of understand what taking a definite integral means. So I thought it might be helpful maybe to just do one more together before we move on to indefinite integrals. So a good problem I think to do might be problem number 6. So let's scroll down to number 6. Okay, we have the integral from 0 to 1 of x cubed minus x minus e to the x plus 2 dx. Okay, I would encourage you to pause the video. Okay, take the time to take this definite integral, then hit play and see if your answer matches mine. Okay, hopefully you've had the time to try this one and see if we get the same answers here. If I integrate x cubed, I get 1/4 x to the 4th. If I integrate x, I get 1/2 x squared. If I integrate or take the antiderivative of e to the x, it's just e to the x. So minus e to the x. And when I integrate a constant like 2, I would get 2x. Anytime you integrate a constant, you're always just adding an x to it. And I don't need the c's here because I know they'll cancel out, so I'm not going to add the c. And I'm evaluating this from 0 to 1, so I'm going to put that bar in and include the numbers. So this is all going to be equal to, and I'm going to do this down below, so I just have a little more room. Okay, 1/4. So the first one we're evaluating that function at 1, so it's 1/4 times 1 to the 4th minus 1/2 times 1 squared minus e to the 1 plus 2 times 1. And then we're going to subtract from it that value at 0, that integral value, antiderivative at 0. Be careful to put that entire term in parentheses because we're going to need to distribute that negative. So we're going to have 1/4 times 0 to the 4th minus 1/2 times 0 squared minus e to the 0 plus 2 times 0. Okay? If we simplify the term on the left, we get 1/4 minus 1/2 minus e plus 2. Okay, so let's do that. We get 1/4 minus 1/2 minus e plus 2, all minus -1, which if I combine all of that together, we get 11/4 minus e, right? So that right there is the area under the curve of x cubed minus x minus e to the x plus 2 from 0 to 1. That's also the change in the antiderivative to that function from 0 to 1. Okay, that's definite integrals. To be honest with you, maybe the toughest part might be actually learning the antiderivatives of functions like cosine or secant squared or sine. Okay, but I think conceptually it seems like we're in a good place. Okay, if you'd like to do some more, the answers are on Canvas. Feel free to move around there and try some more definite integrals if you feel like you need to. All right, the last thing I want to talk about, and it should be pretty short, are indefinite integrals. Indefinite integrals are pretty basic. They're basically an integral with no bounds. Okay, I said think of it as the integral equivalent of just taking a general derivative. So for example, if we think about a general derivative, if I said, f of x was equal to x squared, right, f prime of x would be 2x. Now, I'm not saying evaluate f prime at a certain value. I'm just saying take the general derivative. When we talk about indefinite integrals, we're just saying take the general antiderivative. So if we look at the first one, the integral of x to the 7th dx, we know, at the risk of stating the obvious, we know it's an indefinite integral because there's no bounds there, right? If there are no bounds, it's a key to you that, oh, it's just the indefinite integral. We want the general antiderivative. So using my antiderivative rules, I'm going to add 1 to the exponent and divide by it. So that's going to give me 1/8 x to the 8th. And when I take a general antiderivative, I need to add the c value. Okay? And again, that's just a general antiderivative. I don't need to find any areas under the curve. Just like a general derivative, you're just finding it for the sake of finding it. Same thing here. Okay? And after that, that's pretty much it. If we take a look at number 3, you would use your general antiderivative rules to find it, add a plus c to the n. You don't need to evaluate it. In a lot of ways, it's a lot easier than taking the definite integral because you are not evaluating it anywhere. So as you flip through these, you're going to see that there's a lot of different ones here. If I take a look at a problem like number 7, okay, we really only know how to take integrals of polynomials and some certain ones. So if you look at 7, okay, I might simplify that first into a polynomial but by dividing each term by x, as opposed to trying to do a reverse quotient rule. We don't know how to do a reverse quotient rule, so don't try that, okay? So problem like 8(2), if you're trying a problem like 8, you would want to divide everything by 3x cubed. If you get something like the last term minus, right, 4 over 3x cubed, if you're saying, all right, well, how do I take the derivative of that? I might think of it, okay, as minus 4/3 x to the -3. Bring that exponent to the numerator, and then use our anti-power rule to take the antiderivative of that. Okay? Feel free to do a whole bunch if you like. I'm not going to require that you do any, but it's good practice to do. So I don't know, pick and choose, maybe do some odd ones, do some even ones, and I think you should be good. But there's not a lot of tricks to it. It's just kind of some mechanics on how you take the antiderivative. That's it.